All right. Hello, everyone. So welcome to day 15. It is July 7th. So for Math 133. A lot of people seem are out today, probably because of the holiday still, so which is fine. Uh, Today is the start of week 8 for the class. So if you missed today's class, and you miss Wednesday's class, make sure you come in here to week 8, fill out the discussion board, okay, so that you get your participation points. So if you come to either class 15 or class 16, you don't have to do the discussion board though. Um, so if you have any questions about your grade, let me know. So there's still a lot of things that I'm still working on grading, but where you're at should be pretty close to what you would expect. If you do have any missing assignments, though, those are definitely going to pull your score down. So make sure you get everything turned in. Even if, if you have to turn it in late, that's not great, but still do it, okay? Because part of it is that those assignments aren't just part of your grade, they're also helping you, study for the final and like understand the material, right? Like the purpose for taking this class isn't necessarily like, oh, I want to pass with this grade, right? It's, we want to learn this stuff. We want to know this stuff. So make sure you get everything turned in. Okay. Today, we're going to cover the cumulative review number 5, which is on page 550 in your course pack. So you can pull that out. So cumulative review number 5 is chapters 1 through 8. So we haven't finished chapter 9 yet. We're going very slowly through chapter 9. You'll notice that today the lecture notes 9.2 is what you are assigned, and that's what you need to have done by Wednesday. Okay. Um, so on Wednesday, we're doing a candy project. Very exciting. I unfortunately won't be here in the morning, but Elaine will be. So for the candy project on Wednesday, you need to get some M&Ms and some Skittles. Okay. You will get to eat them. Okay. Don't worry. If you buy them, you're not going to be wasting them. Okay. Hopefully you're not allergic or don't like them. So I'm sure you can find someone who enjoys M&Ms or Skittles. Um, uh, these are your samples, okay? And we've talked about before that when you do an experiment or a survey or a sample, your sample needs to be big enough, okay? I put a joke in the remind that you also can't be too big, but that's pretty rare, right? There's no way that anyone is going to buy 5% of all the M&Ms in the world, okay? That would be huge and super expensive, okay? Um, Usually the issue is that we want to make sure our sample is not too small. So if you buy a bag that's like 3 ounces or more, you're probably good. 2 ounces is probably fine. I did some research that like if you buy like a 1.5 ounce one, which is the normal size, that you only get like 55, 56 candies in there. And if there's 6 different colors, in that M&Ms, then 56 divided by 6, you're only getting about 9, 8 or 9 of each color. Okay. And we know that we need to have uh, from our binomial experiments that n times p times q has to be greater than 10, right? So that's not going to work. So you're needing a little bit bigger than normal. So I would say if you get something that's 2, 2.5, 3, 4, 5 ounces, that's probably good. Um, and then same thing for the Skittles. You want it to be a little larger than the normal bag. Um, the Candy Project is going to be used for Chapter 9, Chapter 10, and Chapter 11. So right here on Monday, where it says Chapter 9 Project, we're going to use the data that you collect from your candy sample for the Chapter 9 project. And then the following Monday, the Chapter 10 project, and then the following Monday, the Chapter 11 project. Okay. You don't need to hang on to the candy that long. You can certainly buy it, do the project on Wednesday, and eat it, but we're going to need the data. We're going to need the numbers for all of those projects. Okay, so make sure you save it somewhere where you're going to remember where to find it. Okay. All right, great. So hopefully you have enough time to go out and buy that candy. We don't like telling people like too early to go get the candy because it gets eaten by kids or by, spouses, husbands that find it. So, um, yeah, that's why we're telling you, like we started telling you last week and we're telling you now. Okay. All right, cool. All right. So anyway, today though is the cumulative review number 5, which is everything from chapters 1 up through 8. So we are going to jump to page 550 in our course pack. Okay. And Joe Hopkins. There we go. Okay. All right. So I'll give you some quick hints and then we'll stop the recording and we'll work on the worksheet. So we've seen this before where we want to find all of these different statistics, or in this case, these are statistics, not parameters, because it is a sample. Uh, is this sample big enough? Well, like we said before, it depends on if you're doing means or if you're doing probabilities. It looks like it's not 30, so it's probably not big enough. But anyway, so we want to look at page 232. And there's a couple methods there. This one, we have the raw data, so this is method 1. By the way, this is supposed to be Q1 right here. Sorry, I missed that. Upper fence, lower fence, we've talked about those before. There's formulas on page 84 for both of those. And then the shape, page 87. Okay. So we keep reviewing stuff that we've gone over before. And part of that is, repetition really helps people understand it. Okay. And part of that is, this is helping us study for the final exam. Okay. Page 87 for this as well. Find the z-score. So page 231 is the formula for z-score. You'll remember that you take the data point that they give you minus the mean and divide by the standard deviation. Okay. Now, this part right here, is it unusual? Okay. People kind of struggled with this on the midterm. Page 80 for the unusual stuff. Okay. There's two ways you can say that something is unusual. Okay. Something will be unusual if your z-score is bigger than 2 or your z-score is less than -2. Okay. That will mean that it's unusual. Okay. The reason why we use 2 and -2 is because those correspond to a probability of 5%. Okay. So if your probability is less than 5%, that's something unusual. Okay. So we've said before, you need to keep track of whether your number that you get is a z-value or a probability. Okay. Because if it's a probability, we compare it to 5%. If it's a z-score, we compare it to 2 and -2, right? And the reason why we use 2 and -2 is because on the normal curve, here's -2, here's +2. 95% of your data is in here. The other 5% is outside of 2 standard deviations, okay? So just be careful with that, okay? In this particular case, it's a z-score, so we're comparing to 2 or -2, okay? All right, page 551. So the following box plot shows the violent crime rate for each U.S. state. District of Columbia had the largest crime rate. Okay. So all of this, by the way, you can find information about all of this stuff on page 85 through 87. Okay, box plots. Most people don't have too much issue with that. Down here, find the following for the standard normal curve, shade and label appropriately, give 4 decimal. Okay, so Um, this is on page 235, parts 1 and 2. Okay. The z-score that cut off the symmetric middle, 97.5%. So here's what I would be shading. Okay. And you need to find these numbers here. Okay. All right. All right. Number 4. All right, page 552. Number 4. So is this coming from an approximately normal distribution? We talked about that on page 163 in our course pack. Okay. Write the appropriate symbol for the given formula. You guys have done these before, so I'm going to skip that. All right, the repair times for air conditioning units are normally distributed with a mean of mu equals 48. Standard deviation of sigma equals 11 minutes. Okay. So page 235, parts 3 and 4. Find the three missing pieces of information. Okay. So um, these you'll notice are not symmetric. Okay. So this x does not equal this x necessarily. Okay. Um, that's okay. So these x's, by the way, these aren't necessarily z's. You'll notice that our axis here, this is not the standard normal curve. So our mean is not at 0, but that's okay. Uh, we can switch our StatCrunch, okay, and type in the mean and standard deviation that they gave us, okay? Um, so in order to get the probability, all of these up here are going to be probabilities, okay? Make sure you're switching it to less than for this part, greater than for this part, okay? You're not going to be able to use symmetric here for this, okay? Okay, provide an interpretation of A1 and X2. So for this part B, we only want to look at these two, okay? You can find that information on page 161, okay? Oh wait, that doesn't make any sense. A1 corresponds to X1. X2 corresponds to A3. This should be X1. That is a typo. I'm sorry about that. So A1 and X1. Okay. So it should be something along the lines of the probability that a air conditioning repair takes this amount of time or less is this probability. Okay. Um, So be sure to include when in your interpretation, be sure to include a direction word. Okay. So those are more, less, or between. Okay. All right. Page 553. Figures show three sampling distributions of sample means randomly sampled from a population with a standard deviation. So this is the population standard deviation. Okay. Sample size is 3, 12, and 16. Figure out which one's which. Okay. Remember that we want larger samples. Larger samples are going to lead to a smaller spread, which means we're going to be more accurate. Okay. If your spread is really wide and you're telling your boss like the, you know, this result or this experiment could be anywhere between this number and this number, and it's a huge range, it's not really going to be helpful. Okay. Okay. So we want to look for the smallest spread. Okay. Um, what is the standard error? So the formula for this is on page 166 for standard error. Okay. Um, the one that has the smallest spread. Okay. So looks like that one would be A. Okay. So for this one, we're going to calculate the smallest or the standard error. Okay. All right. Survey by the verify that the conditions of the central limit theorem for proportions, okay, are met. Okay. So page 170. The example for this is on page 171. Okay. So just like with the one for uh, central limit theorem for means, okay, you still have to check the same conditions. It has to be random, independent, okay. Those two are going to be pretty much the same, okay. You need to make sure that uh, your sample size is less than 5% of everything in the population. It needs to be random, so you just need to find the word random somewhere in here. Part that's different is that it needs to be normal, okay? For means, you just need to make sure that your sample size is bigger than 30. For proportions, you need to do N times P times Q, okay? Your sample size can't be bigger than 10. It's not that your sample size is bigger than 10, it's that you need both your successes and failures to both be bigger than 10. Okay, so that means you need to do this calculation here, put in these three numbers, multiply them together, that equals something, and that has to be bigger than 10, bigger than or equal to 10. Okay. If all of these three things is true, then you can, your sampling distribution will look like one of these, okay? So you'll notice this one looks normal, and that's because this one has a small spread. It's going to have a lot of samples. This one down here, this one only had a few samples, and so it kind of looks normal. It looks a little janky, okay? This one, our samples are not big enough. So the central limit theorem for proportions is not going to be satisfied here. So this is not really going to be normal, okay? I know this is not the same question. That's question 7. Down here is question 8, okay? So if all three of these are true, though, then your shape of your sampling distribution will be normal, okay? Your center is going to match whatever the center for the population is, okay? Uh, in this case, it's your p-value, not your mean. It's your probability. And then your spread is going to be your standard error. Okay. Yes. All right, cool. And there's a standard error formula for proportions that's one step more complicated than for means. Okay. So, all right. So uh, this this review is due on Wednesday. Okay. So if you have any questions, let me know. We're going to stop recording and we're going to fill in all the answers. So we should be done a little early today. So